Hello everybody, my name is David Gunacker. I'm a project manager at IC with specialization on planning of TBM tunnels. And for the beginning I would like to thank my co-author. Other way around. Okay. Yeah. My co-author, Mr. Vladislav Mikhailov, who is not here today. And I would like to inform you that the following presentation is more generalistic and rough comparison between mechanized and conventional tunneling. It's not a presentation which goes fully into detail of how to construct TBM tunnels. Due to the fact that we only have 10 minutes of time for presentation, I would like to start right into it. So when we are comparing the two tunneling methods, it helps to have a look in the final cross-section. On the left-hand side, you see a cross-section of a TBM tunnel, which in general consists of several precast elements made of common reinforced or fiber-reinforced concrete. And due to the fact that the tunneling machine has a higher diameter than the lining, the gap between those two has to be fulfilled with grout or alternatively gravel. It's the orange hatch on the left picture. On the right-hand side, you see a typical cross-section which is made by conventional tunneling, which we in Austria call New Austrian Tunneling Method or shortly NATM. Usually the section is made of an outer spray concrete lining and an inner in-situ reinforced or unreinforced concrete lining. The outer lining ensures the cavity safety by the use of various support measures such as anchors, ledge girders, reinforcement, and so on. After the outer lining is placed and the deformations of the soil have finished, the inner lining gets casted. For the following tables, I would like you to always have those two pictures in mind. So, what are the differences when we have those? When we have a look on those two? The most prominent one, of course, is the shape. Due to the rotating cutter wheel of a TBM, the drive always comes up with a circular shape by the profile. By the use of conventional tunneling, of course, we are able to produce alternative shapes. Due to the fact that the tunnel segments have already implemented sealings at the joints, a TBM drive can come up with only one single lining, which is already watertight. For a conventional tunnel, the spray concrete is not watertight. For the outer lining, the outer lining comes up with a rough surface and can therefore not be used as a final lining in most of the cases. So the inner lining needs to be placed in that case, which of course takes more time and produces extra costs. In TBM tunnels, the lining quality of precast elements is better than in in-situ concrete. But there are many joints within such a tunnel, so we have to be aware of a precise installation. Only precise placed segments lead to a watertight final structure. Since the lead time of a TBM is about 1 year, you always have to be aware that the diameter has to be fixed from the tender. It's not possible to adopt the diameter of your excavation during execution process, which of course is possible in conventional tunneling. And what does all of this mean in terms of economy? For the following always depends on various aspects, such as soil type, groundwater, overburden, machine types, and logistic costs, and so on, many more parameters. But it can conclude that the TBM drive is cheaper than conventional tunneling for drive lengths higher, 3 up to 5 kilometers. The average advance rate is really hard to compare, but from our point of view or our experience, it's hardly, let's say, twice as high by a TBM than in NATM. From the geological, hydrogeological, and geotechnical point of view, the following can be stated. As seen in the regular sections, the conventional tunneling has a different support measure, such as anchors and lattice girders, which can be easily adopted according to the geotechnical situation. In TBM drives, the support is always the same. It's always given by the segmental lining and the gap grouting. So it's a system with a constant support stiffness. The segmental lining, therefore, has always to bear the highest load along a tunnel track. In sections with faulty or weak rock, a profile subdivision in general is made for conventional tunneling. Such a subdivision cannot be done in TBM tunnels. But in comparison to conventional tunnel, the TBM comes up with active phase support. And depending on the type of TBM, we can do the phase support by fluid or active earth pressure and or alternative compressed air application. Due to the active phase support in TBM tunnel, the groundwater in the vicinity of the tunnel not gets lowered, so which leads also to lower settlements in general. In the former days of TBM tunneling, the machines were only able to advance in almost homogeneous grounds. So an EPB, for example, was only able to advance through soil. Today, in the last years, the EPB, the range of application was hugely increased. So an EPB can also excavate rock material, crush it, and can crush it to soil paste by the use of conditioners. Nevertheless, in highly heterogeneous underground, the TBM might need to be modified, which leads to additional interruption of advance. Besides the already mentioned differences, there are other decisive factors which need to be considered when determining the best excavation method for a given project. For example, the logistic effort is way higher when planning a TBM drive. At the temporary segment store, you need on your potential site installation, you need sufficient space for the TBM assembly, for segment storage, for temporary mug storage, and in case of a slurry machine, you need additional separation plant, which takes a lot of space. Further, a high voltage is needed to operate the machine, and many of the spare parts of such a TBM have long lead times, which need also to be taken into account. In terms of worker safety, it can be stated that the TBM ensures less risk of injury and less emissions, such as noise and dust. Finally, one of the main differences for those two tunneling methods can be found in the cross passages. Since the lining is made of precast elements in TBM, the placement of a cross passage along the alignment has to be clear in the beginning. The opening in such a segmental lining is always complex and narrow and hardly to construct, since the connection of the cross passage to the segmental lining has also be watertight. So what can be concluded? From my personal experience, it is possible to design, if it's possible to design a TBM, go for it. It's from my personal experience, it's the better one, due to the fact that there are many pros, such as the high advance rate, the good profile accuracy, which leads to less muck amount, then the lower settlements, the higher safety for workers, and of course also to its environmental friendliness and low impact on groundwater. Due to the high quality of the precast elements, we can produce high quality tunnel which comes up with good durability properties. But there are some points where it is definitely not recommended to design a TBM drive. You have to think on the long lead times. That's the reason why it shall not be used for tracks lower 3 kilometers. The workers on the machine need longer training periods. The site installation is really cost intensive and also takes a lot of space. And in changing underground conditions, you can struggle with performance risks. Therefore, a detailed exploration shall always be done. Last but not least, the profile of a TBM tunnel is always a circle, circumscribing your required internal space. So you always have to be aware of that too. In the end, I would like to thank you for your attention. I would like to briefly advertise the Joint Young Members Austria, in which I'm a member of the steering committee. I would like to invite those participants under the age of 35 to join our organization and perhaps participate in our following events. Thanks.
Thank you very much for this concise comparison of the two most competitive methods, I would say, in underground construction. Are there any questions for Mr. David? Yeah, Vojkan, please.
In your analysis, I missed a few thoughts on that the TBM are watertight tunnels, and they have to take the full hydrostatic pressures. And what is your opinion on that in terms of that we are taking some pressures that we otherwise perhaps wouldn't do, and that obviously have an impact on the size of the segmental lining? Thank you.
You mean the water tightness? From my point of view, it's limited to, let's say, 6 bar. There were projects with even more, but not in the European area. When you have water pressures rising up to 10 bar, you have to think on a different solution. Yeah, because the EPDM gaskets need to be designed for twice the pressure, the water pressure, due to the relaxation of the gasket. So this is almost, let's say, the limit where the gasket can be produced.
Okay, thank you.
Thank you. Any other comment or question? No. Thank you, Mr. Gunacker.